Hello, my lovely students. How are you? Today we are going to start a new topic, that is embedded system design. In that, we are going to learn embedded system overview. So, as we know that computing systems are everywhere, it is probably no surprise that millions of computing systems are built every year for desktop computers like personal computers, laptop, workstations, mainframes, and server. What may be surprising is that billions of computing systems are built every year for very different purposes. They are embedded within larger electronic devices, repeatedly carrying out particular function, often going completely unrecognized by device user. Creating a precise definition of such embedding computing system or simply embedded system is not an easy task. An embedded system is nearly any computing system that other than a desktop computer. That definition will not be perfect, but it may be close. We can better understand that system by examining common example and common characteristic. Such examination will reveal major challenges facing faced by designer of embedded systems. Embedded system, as we can see that embedded system are found in variety of common electronic devices such as, for example, consumer electronics. For consumer electronics we have cell phones, phasor, digital camera, cam recorder, video cassette recorders. They are now past. Portable video games, that is also past. Calculators and personal digital assistants. In home appliances we can also see that we have microwave oven, okay, microwave oven, and we can see answering machine, thermostat, home security, and washing machine, as you can see over here. Office automation. In office automation we can also see that is fax machine, printers and scanners. Business equipment also we can see like cash registers, alarm system, card readers. We can also see embedded system in our automobiles also, for transmission control, cruise control, fuel injection, ABS, that is anti-lock braking system, active suspension. This whole figure gives a brief idea of, we can use it in variety. We are now using everywhere to ease our life in daily use. One might can say that nearly any device that runs on electricity either already has or will soon have a computing system will be embedded within it. Although embedded computers typically cost far less than desktop computers, the quantities are huge. So we can see here that embedded uh, systems are increasing day by day, and we are using everywhere. In medical equipment also we are using, like now we can see that RT-PCR, the test for corona, it is also a part of embedded system. In medical testing system, life support system, everywhere we can see that fingerprint identifiers we are using to for attendance purposes. We are seeing embedded system everywhere. So embedded system have several common characteristics that distinguish such system from other computing system. First will be single function. Okay, an embedded system usually execute a specific program again and again. For example, a pager is always will be a pager, a mobile will be always a mobile, a camera will be always a camera. In contrast, we have a desktop system which execute variety of programs like spreadsheet, word processors, video games, with new program added frequently. Of course, there are exceptions. One case is where an embedded systems programs is updated with a new program version. For example, some cell phone can be updated in such a manner. And case where several programs are swapped in and out of a system due to size limitation. For example, some missiles run one program while in cruise mode. Then we can say that in load a second program for locking onto a target. Second, we can say that tightly constrained. All computing systems have constraint on design matrices, but those on embedded system can especially be tight. Uh, a design matrix is a measure of implementing a feature such as cost, size, performance, and power. These four things is very important. That is, I will write it over here. That is cost, size, we have performance, and power. Okay, these four things is very important. Embedded system often must cost just a few dollars, must be size to fit a single chip, must perform fast enough to process data in real time, and must consume minimum power to extend battery life or prevent the necessity of using a cooling fan over there. Third one is reactive and real time. Many embedded systems must continually react to changes in the system environment and must compute certain result in real time without any delay. For example, a car's cruise controller uh, continuously monitor its speed and react to speed and brake sensor. It must compute acceleration or deceleration amount again and again within a limited time. A delay in computation could result in failure to maintain control of car. In contrast, we can say that a desktop system typically focus on computation with relatively infrequent uh, from the computer's perspective and the reaction to the input devices. In addition, we can say that a delay in those computation, while perhaps inconvenient to computer user, typically does not result in a system failure. For example, uh, consider the digital camera chip as shown in this figure. The charge coupled device, that is CCD. Okay, this one is CCD. Okay, and contains an array of light sensitive photocells that capture an image. The A to D, here it is A to D, the A to D and D to A. D to A you can see over here. Okay, what it does, it converts analog images to digital and digital to analog. This will convert analog to digital, and D2A will convert digital to analog. Hope you understand this thing. This is very important. Everything in real world which we see it is analog, but computer and understand mostly digital thing. So we require what? So mostly what we see through our eyes, it is always what? Analog. But what a microprocessor or microcontroller do, they only understand digital thing. So we need to convert these analog signal firstly for understanding of microprocessor or microcontroller into digital, and their output will be again converted into digital to analog by using D2A devices. So the CCD processor provides command to the CCD to read the image. Um, the image may be of JPEG coded uh, compressors and decompresses an image using the JPEG1 compression standard, enabling compact storage of image in the limited memory of the camera. The pixel coprocessor, as you can see over here, it is pixel coprocessor, aids in rapidly displaying images. The memory controller, you can see over here, the memory controller, what it does, controls the access to a memory chip also found in the camera, while the DMA controller, you can see over here, DMA controller enables direct memory access by other devices while the microprocessor is performing other function. The UART is universal asynchronous receiver and transmitter. You can see over here what it does. It enables communication with a PC serial port for uploading video frames, while the ISA bus interference, in this you can see over here what it does, enables a faster communication or faster connection with a PC's ISA bus. The LCD control, here you can see the LCD control and display control circuit, you can see here, this both will, what it does, controls the display of images on the camera's liquid crystal display devices. The multiplier or accumulator circuit, you can see here, the multiplier and accumulator circuit performs a particular frequently executed either multiplying or accumulate computation faster than the microcontroller could. At the heart of the system is the microcontroller. You can see this is the heart. This is heart of any embedded system. Microcontroller is basically heart of any embedded system, which is programmable processor that controls the activities of all the other circuit. We can think of each devices as a processor designed for particular task, while the microcontroller is more general purpose, designed for general tasks. This example was generally to illustrate some of the embedded system characteristic and described um, in the first slide. Mm, First it performs a single function and then it repeatedly do the function with the help of microcontroller directed by the microcontroller. We are seeing here the system will always act as a digital camera wherein it captures, compresses and store frames, decompresses and display frames and upload frames. Secondly, it is tightly constrained. System must be low cost since consumers must be able to afford such camera, and then it must be small so that it fit within a standard size camera. It must be fast so that it can process numerous images in milliseconds. It must consume little power so that camera's battery will last a long time. However, this particular system does not possess a high degree of characteristic of being reactive and real time, as it responds only to pressing of button by the user. Unless user will not press the button, it will not click uh, the photo and it will not appear, which is even in the case of an avid photographer is quite slow with respect to the processor speed. uh, in next class we will learn about design challenges and optimizing design matrices. Hope you have understood this whole lecture. You have watched video till now, definitely like the video, so press the like button. If you are new to the channel, please subscribe the channel. Thank you for watching. Jai Hind.